Hi, today we're going to talk about sample space and events. So let's look at some vocabulary. The sample space, which is going to be U, is going to be the set of all possible outcomes. And remember that U stands for our universal set. So instead of calling it a universal set, we can just call it a sample space. They are synonyms. Then we have that an event is going to be the set of outcomes that are in that sample space that have a particular property. So example 1 states that you have a normal six-sided die and it's rolled once. Let A be the event that a composite number is rolled. So remember, a composite number is a opposite of a prime number. And a prime number by definition is a number that can only be obtained by having the product of 1 and itself. So any number that can be divided by or divided evenly by any other number other than 1 in itself is what we consider a composite number. So the fact that we are rolling a six-sided die lets us know that we have 6 outcomes. So in our universal set, that's going to represent the size that we can roll. So we can either roll a 1, 2, 3, 4, 5, or 6. So A is going to be the event that a composite number is rolled. So if you roll a composite number, that means you can either roll a 4 or a 6. And part 3 is wanting you to write the set that you are not going to roll a composite number. Remember that apostrophe means not in math. So that means that you will have to roll a prime number, which is 1, or a prime number or 1 because 1 is not prime. So you can roll 1, 2, 3, or 5. Basically all the other sides that are on the die except for 4 and 6. So if I want to use a Venn diagram to illustrate it, I'm going to draw my rectangle for my universal set, and I'm going to draw a circle, and I'm going to label that circle A. So the set of numbers that are in A are 4 and 6, and the set of numbers that are not in A but still inside of the universal set is going to be a 1, 2, 3, and a 5. And remember, you always want to label your rectangle with a U because that tells you that that is your universal set. All right, so let's look at example 2. It says, illustrate possible outcomes when 2 coins are tossed using a 2-dimensional grid. So what that means is that I'm going to have an axis for each coin. So I'm going to have an axis for coin 1, and I'm going to have an axis for coin 2. Now, when you flip coin 1, you have 2 outcomes. You can either get a head or a tail. Same thing for coin 2. You can either get a head or a tail, which means that there are 4 combinations. You can either get 2 heads, you can get a head for coin 1 and a tail for coin 2, or you can get a tail for coin 1 and a head for coin 2, or you can get 2 tails. So that is how I will represent that in a 2-dimensional grid. Some people draw circles in place of writing the letters on their 2-dimensional grid. If you do that, that is fine. Okay, that is fine, but it does not matter. The other thing you can do is you can draw a tree diagram. So you have 2 coins. So the first one we're going to draw is if you're flipping coin 1. If you flip coin 1, you can either get a head or a tails. Okay? So once you flip coin 1, you have 2 outcomes. Depending on what you get for coin 1, you can get 2 options for coin 2, which is also going to be a head or a tails. If you happen to flip a tail for coin 1, when you flip coin 2, you can still get a head or a tail. So this is how you will represent it in a tree diagram. All right. So as you can see here, you have 4 outcomes. So in a tree diagram, you can either get 2 heads, You could get a head and a tail. You can get a tail first, then a head, and let me use a different color. Or you can do a tail and a tail. So basically, you have 4 outcomes here. And those 4 outcomes can be listed as a set. So 2 heads, a head and a tail and a head, and then 2 tails, if you would write it in set notation. All right, so now let's look at example 3. Example 3 says, use the tree diagram to illustrate the possible outcomes when the spinner is spun 3 times. So we're going to have 3 sets of branches on the tree diagram. And it says, highlight the outcomes corresponding to the event obtaining white twice. So you want to write out how you can obtain white twice. So when we read a tree diagram, we read it like a story from left to right. So we're going to have on spin 1, we can either get a blue or we can spin a white. So that is spin 1. After you spin the first spin, then you can either get on spin 2 a black or a white, a blue or a white as well, excuse me. So that is going to be spin 2. And then on the third spin, you can either get a blue or a white as well. And sorry if I say black, I'm just used to using improbability. We normally do black. But same thing, same concept. So this is going to be the results if you have 3 spins. All right, so if these are my 3 spins, then I should be able to list all of my outcomes. So remember, when we read a tree diagram, we read it from left to right. So my outcomes are either going to be that I can spin all blues in a row, or I can spin 2 blues and then a W, or I can spin a blue and then 2 W's. Or excuse me, a blue, a W, and then a blue, excuse me, and then a blue and 2 W's. If I spin a white first, I can spin a white and then 2 blues, or I can spin a white, a blue, and another white, or I can spin 2 whites and then a blue, or I can spin all white. So when it says highlight the outcomes of corresponding to the event of obtaining a white twice, then I know that in order to get a white twice, I can spin a blue, a white, and then a white. Or I can spin a white first, then a blue, and then another white. Or I can spin a white and then a blue. So there are 3 ways that I can spin and get 2 whites. If you have any questions, please let me or your teacher know, and have a great day.